Hello Internet, I'm Remote Leg, and welcome to the LifeStyles project, a study of A-Life. I've been thinking about our A-Life prototype from the first video. Remember this? We're looking down on a map where the original numbers represent living creatures, the grey numbers are piles of waste, and the white squares are empty. Yes, it's a boring world, but why is it boring? It's boring to look at because it's just a bunch of numbers, big whoop. But the lives within this simulation are also boring because the world offers little variety. Any of these squares can only contain either life, poop, or nothing. Not much room for diversity, is there? Not much choice. If we want evolution to produce a rich assortment of species, all competing for resources, we need to give them a world with a rich assortment of resources to compete for. That's my thought. Boring worlds produce simple species, so I need to build an exciting world to give them opportunities. I think this is quite important. Of course, the mechanics model I built for the last video will help. Atoms floating randomly in space can combine in many ways, and I've modeled some mechanics in Microsoft Excel. This is a top-down view of a two-dimensional plane where each particle has mass and exerts attraction, gravity if you will, on its neighbours. The particles bounce around the screen, briefly interacting as they come within each other's gravitational fields. I really like the graceful way the lighter particles orbit the heavier ones. If I add some friction, they might even coalesce into blobs. Excel is good for these proof of concepts, because I can get something up and running without a huge amount of effort. But Excel has its limitations. Look what happens when I go from 7 particles to 26. Notice how the graceful orbits had become a little jerky? That's because Excel is doing an awful lot of work calculating the trajectory of each particle, and it's starting to break at the seams. It's time we move up to a bigger engine. Enter Microsoft Visual Basic. I've rebuilt the whole project in VB. This is a compiled language that offers a lot more performance than an interpreted engine like Excel can offer. And a bonus, the increased power of VB has allowed me to model in 3 dimensions. Yes, this map is still looking down from above, but particles that move higher get slightly larger, and those that fall to the lower altitudes get smaller. This is just a visual cue to let us know that things are working properly, but it's nice to be able to add a 3rd dimension to the world. Other languages would work equally well. C springs to mind, but VB offers 2 big advantages. One, it's similar to the Excel scripting language, so translation from one platform to another is simplified. And 2, I'm a pretty decent VB coder, whereas my C language skills are a little rusty. So VB it is. Here's some VB code from the program we just saw running, and here's some Excel code from the program that struggled to handle 29 particles. As you can see, the syntax is fairly similar, so that makes it easier for me to port my Excel code to VB. It's not identical, but it's close enough. Okay. Let's pile on the workload and go with 300 particles. Unfortunately, it's as I suspected. At 300 particles, even VB is starting to sweat, and our graceful orbits are once again starting to get jerky. I was hoping to build a world out of these particles, but how many are we going to need? 3 million? 300 million? I'm thinking more. How many grains of sand are in a cubic meter of beach? That's right. 8 billion. Imagine what the performance is going to be like if we try to model a small square of beach. If I was running a supercomputer, we might have a chance, but my poor old PC is just not up to the task. Let's not get discouraged. We just have to work smarter, not harder. Remember the goal, to create A-Life. Do we really need to model every atom? It would be more correct if we could, but we can't, so we need a shortcut. Let's think about this for a moment. Right, I think I have a solution. First, I'm going back to 2 dimensions. In a world cube of 300 locations on each side, removing 1 dimension is a reduction of over 26 million locations. That's a good start. I'm no longer modelling atoms. Instead of storing 81 oxygen atoms at a location and calculating their gravitational pulls and trajectories every cycle, that location will just record a single oxygen field with a quantity of 81. Of course, altitude will have to be calculated if we want to avoid a perfectly flat world, but I can worry about that later. I'm pretty confident I can create consistent physical laws that will let A-life creatures make sense of it all. So that's the plan. I guess I'd better design some data structures before I start coding. This is getting interesting. I'll try to have a working prototype next time we meet.